Hi all. Thanks so much for joining the call today. I'll be your host. My name is Berto. I work at Parity, working alongside some of our Polkadot parachain teams, and today I'm joined by Rob Habermeier. For those that don't know, Rob is or a co-founder of Polkadot, working alongside Gavin and the team from day one. Rob actually wrote most of the Polkadot core code, which is responsible for producing and finalizing blocks. And today we're going to be discussing some of the very exciting and upcoming technical changes that Rob and the team have been working on for the last 9 months. So this is specifically pay-as-you-go parachains and async backing, which you may have heard about before if you follow him on Twitter. Now that is a little bit of a mouthful, but we're going to go into it in a lot of detail, so don't worry. We have a pretty packed session today. We've got a lot to chat about. Cool. So first, Rob, welcome. Can you tell us maybe just a little bit more about yourself?
Yeah, sure. Hey, Berto, thanks. Thanks for hosting, and thanks for joining everybody. There's not that much to tell. I've been working on Polkadot for a long time, since the beginning. I started working in the crypto space around 2015. I was digging into Bitcoin and stuff, for a few years before that. But I'd say it was Ethereum that really brought me into the space where, I saw Bitcoin and that it was useful and people could send money and sort of script it a bit. But Ethereum, when I started following that, was really interesting with, what they could do with smart contracts and executing Turing complete code. And the promise of it, I think, was much better. And that's when I started to really look around. I've been working in the Rust language for actually around that long as well. So I first poked around in Rust like in late 2013. It was very different from today. And I ended up landing with, Gavin and the F Core team, which became Parity Technologies, in 2016, just by poking around on GitHub and seeing, hey, these people are doing Ethereum stuff with Rust. I was interested in Rust because of performance, because of security. My background, I used to do a lot of CTFs and computer security competitions and things like that. And Rust solved a lot of the problems that those competitions, you had to exploit. So when I saw they were doing Ethereum stuff and Rust, I started to work, contribute on GitHub, get in touch with these people, and then we started to dig into to Polkadot.
Nice. And I guess what was the kind of sparked your interest to diverge from Ethereum and do Polkadot?
Yeah, I mean, it was actually, I'd say, fairly gradual. I still really like Ethereum. I have a lot of friends in the Ethereum space. There's a lot of cool stuff going on there. I think one of the things that sparked my interest was sort of this desire for experimentation. Wanting to move quickly. Like Ethereum had already launched and had to move a lot slower. As a result of that, I think experimenting with new mechanisms, starting to bring together some of the emerging technologies like WebAssembly, which in 2016 was a new thing, right? People were just starting to look at WebAssembly. Now in 2023, I think it's very concrete and the tooling has evolved a ton. But it was this idea of saying, hey, here's Ethereum and Ethereum as it is, and it's pretty interesting, but let's keep playing with ideas. Let's keep going back to the drawing board and saying, what can we change? And that's, I think, what really drew me to working deeply on Polkadot at the beginning, was saying hey, let's try something different. Yeah.
Yeah, okay, that makes sense. Cool. Okay, so let's dive into the meat of it. Let's talk about first the pay-as-you-go parachains. Could you give us, maybe for anyone that hasn't read your blog or looked at the Polkadot forum or anything like that, could you kind of give us a bit of a TLDR in a very, very simple way of kind of what it is and what it helps to achieve?
Yeah, I mean, I might diverge from this a little bit because I think it would be helpful to talk a little bit about this notion of block space and how it fits into to users, to give some grounding for pay-as-you-go parachains before I get into that directly. But we can talk more about Blockspace as we go on, but the basic idea is, what are these blockchains actually producing? What is the end product of all of this decentralized consensus that we're doing? And formulating that in a way that's useful to people who are building on top of it and using it. That's where we get this notion of Blockspace from. Treating it as a raw material, right? And when you treat it as a raw material, it's like you have producing it, you have a steel factory, right? You have a block space factory. This decentralized consensus is block space factory in essence. But it does more than that because we also have to decide how you allocate the block space, right? Like you have this idea, I think, of a blockchain that's been cemented over many years of a blockchain being something that you spin up, it runs, it makes blocks every so often, usually at a regular pace or like at least roughly a regular pace, and then it just runs forever. So a lot of what we're doing is trying to reframe the conversation and reframe the product offering, look at different ways to make this useful by sort of flipping that notion upside down. It's like there's this raw material block space that you can allocate in a lot of different ways. And this is where we get into stuff like pay-as-you-go parachains. So the idea of a pay-as-you-go parachain is essentially you're building a blockchain, but hey, you're building something that is early stage, right? It's experimental. There's not much point in like paying validators to make blocks that are empty for you, right? If you don't need that. This is actually wasteful, I think, from just a pure like economics perspective. So the idea of pay-as-you-go parachains is the idea that of creating a mechanism in Polkadot for somebody to build a parachain, a blockchain. It's something akin to roll-ups if you're coming from more of the roll-up world. There are a lot of commonalities there, but you're building this blockchain, but you only make blocks when you need to make blocks. So having mechanisms for essentially getting block space on demand is what pay-as-you-go parachains is about.
Okay, I mean that sounds, for me at least anyway, sounds pretty exciting, and I think it addresses a lot of kind of issues and things we've seen where there's underutilization of block space, right? So maybe as a kind of a team that is looking to build a new chain, could you kind of maybe talk about how this makes it easier for this team to kind of get started and have maybe lower cost?
Yeah, absolutely. So there are, I think, a couple different factors to address here. So one is that right now Polkadot is only offering block space in bulk, right? It's like the difference between buying a t-shirt at the store and buying a shipping container full of t-shirts. Like you can be fairly efficient by buying a shipping container full of t-shirts, but if you're one person, then you don't need that much, right? At least initially, as you scale, your business or whatever, your institution that you're building, you might need more than that. The way that it makes it easier is essentially it brings writing a blockchain closer to something like deploying a smart contract. It's, I think that the end goal of pay-as-you-go parachains should be you write a piece of code which defines your blockchain, you upload it to the to Polkadot, and then fund it, and it goes, right? So that's very close to something like a smart contract. It's not all of the political stuff of getting validators, right? Organizing even token distributions in the same way. I think it'll remove a lot of the legwork, technical and economic and planning and funding that's needed to launch a blockchain. So I think it should make that a lot easier.
Yeah, that sounds amazing. And I think like another maybe comparison you've made in some articles is it's kind of similar to how AWS does compute, right? You can have on-demand compute, or you can have like scheduled, like reserved instances and that kind of stuff.
Yeah, exactly. I mean, if you think about the current parachain slot offering, basically this bulk offering where teams are, there's a certain amount of slots and teams are competing in auctions in order to secure this bulk block space. This is something akin to a reserved instance in a cloud model, where you're buying in bulk because you have predictable demand, because you have to service that demand and you want to get it all up front. But cloud services also offer spot instances, and pay-as-you-go, parachains or other offerings in the future can help service transient demand, right? I think a parallel to Web 2 would be, your website is serving 1,000 users most of the time, and then every once in a while it bursts up to 100,000 users. So pay-as-you-go parachains can also be combined, not in the initial release, but that's part of our roadmap for the next year after that, is to allow these offerings to be combined in such a way to serve as transient demand.
Yeah, that's cool. That's super exciting. And so what kind of changes does this like pay-as-you-go parachain model bring for existing parachains? So anyone that's, launched in the last year or so, what could they expect to kind of see or leverage with this new model?
Well, I think many teams, for the teams that have, or for the projects and products that have bulk block space, nothing will change, right? They still have that block space. That's something that Polkadot's governance, I expect, would guarantee. So, nothing needs to change in anybody else's code for the moment where pay-as-you-go parachains launch. Now, it could bring changes maybe strategically for certain parachains, right? Or at least projects that are going for parachain slots, where they might decide that they're better off as a pay-as-you-go parachain, right? That it's more economically viable for them to do that. So it definitely, I think it opens up more strategic options for them to do that well, not forcing them to adapt anything in particular.
Okay, nice. And it kind of sounds like, from what I'm hearing, these changes can start to kind of fuel this like app chain or app-centric narrative that we've been speaking about quite a lot. Would you agree or disagree, or have some thoughts on that?
Well, it definitely makes things more possible. I think we are when we look forward to what does it actually take to grow an app and build an app or an app chain, you have to account for the growth curves of these things, and it's usually exponential, and it usually has a very slow start. I think it's very important, especially for applications or really anything that's pre-product market fit, to be economical with their resources, especially given current economic conditions and current crypto market conditions. I imagine this is on front of mind, right? We're not in 2020, we're not in 2021 anymore. We're certainly not in 2017. So I think that changes a lot. I think it's this has implications for app chains, but if we look at this block space resource, right? So we have a raw resource, which is something like, I think a good parallel is something like steel, right? Like I-beams, or just raw steel, raw inputs. And then you're going to have ways of transforming this into intermediate products. Maybe some kind of like widgets, things that are useful for building things, but you're also going to have transformations of this raw material into end applications for users. So it should have implications for all of that, essentially, for those operations to grow and scale economically.
Yeah, nice. Okay. And have you thought about, or has there been any thought yet around pricing? So say, for example, if I was a team and I was to run a pay-as-you-go parachain like full-time 24/7, do you think that would, basically just be a parachain?
Yeah, I think it would probably end up being more expensive to do that, to just continuously buy, right? It's buying t-shirts off a rack, but you're buying hundreds of thousands of them. It gets expensive more quickly. As for how the actual pricing model would work, there's a post on the Polkadot forum about this, which kind of elaborates the current design. And that is that it'd be something like a moving spot price, right? You have a certain target, and when demand is high, the price moves up. When demand is low, the price moves down, probably down to some fixed minimum, right? Like it doesn't really make sense for Polkadot to give away block space for absolutely nothing. And the core unit of Polkadot's system is something we call an execution core. So we kind of think of Polkadot as like you have a big decentralized CPU. And this analogy works pretty well. It doesn't work perfectly. You have a big decentralized CPU. And just like a CPU and an operating system on a computer, you have many different programs. And these programs are parachains in Polkadot. So you have scheduler, and the scheduler says which programs want run on which cores at which times. So the effect would essentially be that you have Polkadot's governance, which is deciding like how many cores should be exposed based on things like the current mechanisms in the code, how many can be supported, how many validators there are, how much economic security, how much demand. You have all of these things that go into deciding governance, how many cores should be exposed. And then it's a matter of deciding, well, of those cores, how many should be allocated to bulk, how many should be allocated to pay as you go, and things like that, which would also influence sort of the supply, the relative supplies of like pay as you go parachains versus bulk slot offerings, and yeah.
And do you imagine that is something configurable via governance, or something that's kind of hard coded in and then test and learn?
No, absolutely configurable by governance. Like the design philosophy has always been, if it's a knob that can be tuned, then governance should have access to it.
Yeah, nice. Okay, great. That's good to hear. And so, what kind of changes do you think this might have to the current kind of auction process that we're seeing now of one chain coming online every X period?
I mean, I think it remains to be seen. Like, there are a bunch of other future plans with like, dealing with the current auction process. I think it should address the misconception that, there are a limited amount of chains that can connect to Polkadot or run on Polkadot, because as you get pay-as-you-go chains, parachains, you could imagine 10,000 or 100,000 chains all running on Polkadot. They're just scheduling their block space a bit differently. This doesn't directly impact the auction process. There are more ideas around that I can expand on. But I think the main difference would essentially be like governance has to make this decision, right, based on the demand that's being seen and predicted in the market as for how people want their block space to be packaged, to make this decision between how cores are allocated between the current auction process and the pay-as-you-go process.
Yeah, okay, that makes sense. With these changes coming in, do you think that we might see some changes to the current auction process? So, for example, like a decrease in number of available slots per year, or maybe like a minimum fee, to get a slot?
Yeah, I think that's very possible. Especially once there are other options, right? So the main thing that pay-as-you-go parachains brings in this is that, Polkadot can limit the amount of slots that are available in the bulk auction process, but there are still many on-ramps and lower barriers to entry for people to join. So I mean, this is something that governance will have to decide, and it depends on factors like how many cores can be exposed. But I think that those proposals are certainly on the table.
Okay, nice. And I think the last kind of question I had in this area was around like community participation. So, we've seen some really interesting things happen with community participation with crowd loans. Do you think with like a pay-as-you-go parachain model, that is something that could still be possible?
Not in quite the same way, because the price for paying for a single block of a parachain should be pretty low, right? So there's no real demand for like lots of crowdfunding in that. I think there are interesting things that can emerge with this, right? With like tokenless parachains and things like that, where essentially you have a current model of reimbursement for creating blocks, right? The current model is in pretty much all blockchain systems is somebody creates a block and does work for that, and then gets paid in the token in order to do that. And I think that with like pay-as-you-go parachains, there's sort of an avenue for community participation in the sense that you can separate out this reimbursement, right? So like kind of anybody, as long as the parachain supports this, could say, hey, you know what, I want to pay for a block for this parachain and sort of help it scale and maybe get rewarded for that.
Okay, that's cool. That sounds pretty exciting. I'm interested to hear more about that in the future as things develop. One other question that I have here actually is around like the possibility of using like a pay-as-you-go parachain to help do things like revive bricked chains. Do you think this would be possible?
Yeah, well, specifically, I think it ties into the conversation of, hey, what happens when your slot ends on Polkadot? So, it goes one way, which is, you start as a pay-as-you-go parachain, then you can upgrade to a parachain slot, like a bulk option. So that's a nice on-ramp, but it also works in the other direction, which is that, let's say the market is getting really competitive for parachain slots, and it's hard for certain projects to hold on to them. If that's the case, then it's not like your chain just stops, right? You just turn back into a pay-as-you-go parachain, and then the project can continue, and maybe then it can win another bulk slot, or use some other offerings that might come up in the future to continue its operations as well.
Yeah, nice. I mean, that makes it sounds like it makes it much easier for chains to like swap leases and do lots of different things there. So I think that will be pretty welcome by everyone.
Yeah, for sure.
Okay, cool. Let's chat about async backing now. Also, there's some links posted at the top, like pinned at the top of the Twitter space if you're on mobile. I'm not too sure about desktop. So if you want to like read a little bit more about what we're talking about, if this is the first time you're hearing about it, you can click. There's two links there, and there's like a lot more detail if you want to go into it. So feel free to read after the call or at your leisure. So I wanted to chat about the like asynchronous backing. This is maybe the more complex of the two. Could you again kind of give us a bit of a TLDR, explain like on five of what async backing is, and then again what it helps to achieve?
Yeah, definitely. So coming back to the block space material, right? You have two main things that need to be done. One is create more block space, right? Manufacture as much as possible. The second is to allocate it efficiently to those who need it most at any given time. So pay-as-you-go pair of threads is an allocation question, whereas asynchronous backing is optimization. It's increasing production of block space. It's scaling. There's a lot of technical details here to get down to it. I think that the most important takeaway is that it's a major optimization or set of optimizations, and then it's laying the groundwork for some other interesting things like parachains that make blocks, multiple blocks at a time, very fast block times and elastic scaling, and some other stuff we can talk about. From a technical perspective, what asynchronous backing is well, what backing is the initial process of some validators in Polkadot, sort of receiving a parachain block, signing off on it, putting some skin in the game in case that turns out to be bad later. What asynchronous backing is essentially a decoupling of this process from the growth of the relay chain itself. So with the current version that's deployed of the backing code, the process of how validators get blocks and how new parachain blocks are created is very tied to the progression and growth of the relay chain of the main chain of Polkadot itself. But by separating it, you can do stuff like pipelining or buffering. You always have a block ready to go as soon as the previous one comes in and gets included and finalized. So that's the heart of that optimization.
Sounds like then we're going to see quite a lot of speed increase with kind of block time and like if you're talking about this kind of like semi-parallel, maybe not parallel execution, but like scheduling. Could you maybe talk about some of the kinds of speed increases that we might see with these changes when they become live?
Yeah, absolutely. So I think that the most surface level one, which is still important, is it's aiming towards 6-second block times on parachains. So you have 6-second, parachains currently take 12 seconds. They can only include blocks every other relay chain block. This would get them down to 6 seconds because there's always another block ready to include as soon as the previous one goes in. But the other artifact of this is that it allows us to allocate more time, or for collators to spend more time on executing blocks. So on creating them and executing them. This is a good thing because, so from an estimate, let's say currently collators and validators spend about half a second executing each parachain block. We're trying to get this up to 3 seconds. So that would be 6 times as much time, plus blocks coming twice as fast. The other aspect of this is that because of many details of this set of optimizations, it gives more time to distribute data, which means that parachain blocks will be able to make more data available. Now, I'm a bit reticent to talk about concrete numbers because the code just became feature complete last week, which means that we can actually do benchmarks now. But that benchmarking and load testing process is currently undergoing. Before that's completed, I can't say exact numbers, but this sort of, these are the rough parameters we're dealing with. Twice as fast parachain blocks with 6 times as much execution time.
Sounds like faster.
Yeah.
In the kind of crypto space, like we see, on a lot of blogs and like different websites, there's a lot of discussion of different, metrics for blockchains, with lots of big tables and lots of like numbers and comparisons. One of the ones that people, always seem to compare is like TPS. And I was kind of wondering, like this will obviously make things faster, but do you think it kind of makes sense to compare blockchains by these metrics?
I think when you're getting down to the core resource of Blockspace, what really matters is how much time are you spending executing? So basically, how many CPU cycles you spend on a particular, executing a particular block, and how much data can you access in that block. So those are the two things. It's essentially data size and execution time. And this is a proxy for transactions per second, but transactions per second is a very, it focuses on balance transfers. Is that to random accounts, right, where you have to create new accounts when you're transferring to them? Is it all to the same account? Those kinds of things, like, really muddy the waters on what this is actually measuring. And it's not clear that it's a great proxy for actual throughput and utility, especially as you get into more complex applications.
Yeah, okay. Sounds like a bit of a vanity metric, is what I'm hearing.
Yeah, it is a bit. I mean, it's not totally useless for sure, because it's a proxy for something, right? And people care about transferring and making transfers, but it's not a proxy for all of the things that you could do with a chain.
Yeah, I guess there's a few other things you can do, like on a blockchain, other than just transfer funds and make a new account at the same time, right?
Yeah.
So with these changes, like for async backing, how do you think this kind of helps, like scale Polkadot beyond like how it is able to scale now?
Well, it lays a lot of groundwork. Like, asynchronous backing is going to have some immediate benefits, which I discussed a bit earlier: faster parachain blocks and more execution time and more data. But it lays a lot of groundwork for essentially some of the ideas that we have around elastic scaling or other scaling improvements, essentially sort of boosting, parachains. The idea that you have a sustained demand that requires 1 block at a time. Sometimes your chain experiences higher demand, which requires 3 or 4 blocks at a time. And asynchronous backing really lays the groundwork for a lot of the stuff that you need to do this, like making many blocks at the same time, parallelizing block production, essentially, creating 4 blocks at a time, shipping them all off to the Polkadot network by having 4 execution cores at the same time. So I think that'll help scale, in particular, the use cases. And that's, it's interesting. This is a set of optimizations that's mostly focused on increasing the amount of block space available, but also lays groundwork for some of the really interesting allocation stuff that we can do. Because demand on all projects using Polkadot is not going to be even at all times, right? Some projects that are built on Polkadot, some chains, are going to be higher demand drivers at different times. I think it's very important for them to be able to scale on demand as well. So, the idea that, let's say, you're able to get 4 cores at the same time, asynchronous backing kind of lays the groundwork for this. There's more to be done. But one of the things that comes out of that is, like, your chain is doing 1x, but then you experience higher low, so your chain can boost up to 4x speed. temporarily, and then go back down to 1x when that is lower. You can build all kinds of markets and things on top of this as well.
That sounds pretty exciting. I mean, I think that we've seen a lot of issues with network congestion on other chains. So I think this sounds super exciting because it can help kind of smooth out that quite a lot. Does the async backing changes and like pay-as-you-go parachains, are they deeply intertwined, or are they potentially able to be submitted moved to the network individually?
Yeah, I'd say that they're mostly not intertwined. There are a few areas of overlap in terms of the parts of the system that they touch, but in principle, they don't really affect each other much at all. So I wouldn't expect those to even land at the same time, but rather that these are both things that are going to happen this year and are underway.
Gotcha. Okay. And so around the kind of like soft cap of parachains, there's always been discussion of kind of like 100 parachains. Sounds like the changes for both pay-as-you-go parachains and async backing would like exponentially increase that number, right? Do you have any thought around what that could potentially be in the future?
So in practice, pay-as-you-go parachains raises this cap a lot. A lot of the other offerings that we're discussing in the forum, forum.polkadot.network, I think open up more options for having more parachains. The truth is that asynchronous backing, because it leads to cores being more heavily occupied, actually increases the amount of load on the network. So it, to some extent, hampers scaling, but only because we're using the network more efficiently. So it actually doesn't have much effect there. I think the biggest effects in scaling the amount of execution cores, that is growing the CPU of Polkadot, are basically going to be twofold. One is just code optimizations. The code works, focused on security, focused on getting things right. There's a lot of optimizations and a lot of people working on optimizing the network code. I think that's going to lead to a pretty significant uptick in the amount of cores that Polkadot can expose over the next 12 to 18 months. And then there are other approaches like, what about instead of having one CPU, one relay chain, you have many that share a validator set. Things like this, these are the approaches I think that are going to increase the number of cores. Asynchronous backing is more about better effectively utilizing those cores and making sort of the cores more powerful. It's an upgrade from a Pentium to a new Intel.
To a Threadripper, maybe.
Yeah.
I heard you mention multiple relay chains, and I assume that some people in the audience's ears kind of perked up a little bit. Has there been much thought around that? Is there anything else you could potentially share or discuss around that concept?
Well, there's nothing formally written up. It's a path for scaling that's being explored by research at Web3 Foundation. I think the most comparable paper that's been published that could be a reference and kind of is an inspiration for this model is a paper called OmniLedger. I think from 2017 or 2018. The details of that aren't settled, and to be honest, I think with the current state of the crypto market, right, and the state, not just market, right, but how people are utilizing it, scaling is not as important as efficient allocation. So this is something I think that we're going to be digging into beyond like elastic scaling and looking into that more. And we'll talk about it more then, but now it's a bit light on the details.
Yeah, okay, makes sense. And with async backing, are there any kind of security considerations that chains might need to have, or like people building on the network might need to have?
No, it doesn't change security at all. So this is kind of the beauty of the optimization. All of the security of Polkadot is driven by a protocol called approval checking, which it's essentially an interactive proof protocol. That's not really an important detail, but this only affects the backing, like essentially the parachain block creation and extension phase. So that actually doesn't impact security because that phase is only about getting skin in the game for approval checking later.
Okay, nice. And are there any kind of like MEV considerations or opportunities here with these changes as well?
I think there will be a lot of MEV opportunities that emerge as this, especially when it comes down to the parachain side, because we're talking about like the core changes, like how validators communicate, what Polkadot will offer, where parachains will have a lot of flexibility in how they choose to make blocks. What are their fork choice rules? What opportunities? I mean, MEV opportunities either come from, you know, having the right to make a block and choosing what to put into it, or choosing not to make one at all. And I think that this definitely increases those amount of opportunities, doesn't lessen them.
Okay, nice. And so like these changes all sound pretty exciting and pretty big, to be honest. I assume that these will not be like a hard fork change to Polkadot, right?
No, it won't be. It won't be a hard fork. It's not a pure runtime upgrade, but essentially the way that the rollout plan will work is you'd have the nodes upgrade, and it would be fully backwards compatible node version. And then when Polkadot governance decides to, it can basically just flip the switch and upgrade the runtime version to like the business logic of Polkadot relay chain to say, hey, this is enabled now.
Okay, nice. And so what kind of time frame are you thinking? Like you mentioned the work is kind of feature complete now, and I assume it's going to undergo an audit and have a significant amount of testing. Well, like when do you think people might see this, like even roughly on Kusama or Rococo maybe?
Yeah, so to be clear, like asynchronous backing is feature complete on the Polkadot side, and that's undergoing audit right now. Now it's a lot of code, so those audits are going to take a few months. Once it's audited, it should be ready to deploy. So it's going to happen this year. It depends, on the audit process. To be honest, like the testing that we've seen shows that it's working fine, but the audit might turn things up, and that will take things back to adjustments and so on. Whereas pay-as-you-go parachains are in the design phase, but it's a much smaller feature overall, which won't take as much time to develop. So both, I mean, the most realistic I could say is this year for sure, probably second half of the year for both. But we'll see, and we'll keep you posted on how those developments come along.
Okay, nice. And what are the, like assume this all goes live, like what are some of the major outcomes that you're predicting?
Well, to be honest, with asynchronous backing, like I think it's going to be nice for teams to have more, more consistent block times, potentially, or faster block times, more execution. They're probably not, many teams at least aren't using all of their block space right now. So, that might not actually have an impact, but it does send a good signal about Polkadot's ability to scale further and lays a lot of groundwork. I think pay-as-you-go parachains are actually going to be very, very impactful for the ecosystem in the sense of lowering barriers to entry. There are huge efforts that we can undertake around the launch of pay-as-you-go parachains, like hackathons, and really showing people how to use these in a way that makes it clear just how easy it's going to be to deploy onto Polkadot. As well as like some of the stuff that's being built in the community around launch pads, making this even easier than just what's deployed in the Polkadot core protocol, but really just getting that as close to the level of deploying a smart contract, where you upload code, you pay, you go. That I think that's going to be have a really big effect on ecosystem growth, right? Just like bringing more teams into the ecosystem, letting people experiment a little bit more freely than the current mechanisms do.
Okay, nice. And actually, one of the things that I forgot to mention, well, there's two things I actually forgot to mention, but in one of the forum posts, you kind of wrote about like secondary market for Blockspace, and like you kind of mentioned then, like a launch pad of people able to kind of come and like purchase Blockspace or sell Blockspace. Like you mentioned, some teams are not using the full capacity. Like it sounds like teams that are not using the full capacity could potentially like sell that out to other teams that were looking to scale or looking to kind of just get started. Is
Yeah,
that
exactly.
correct?
So on the core side, we want to set the right primitives that allow markets to be built outside of the explicit core consensus. And I talked about a few different things there. But the idea is that, if you're buying bulk block space, but you're not using all of it, you should have the ability to resell it. And, split it either by okay, I'll have a chain for 6 months and then you'll have a chain for 6 months, which maybe isn't that useful. But if a project is sunsetting, maybe it is. But the other thing you can do is if you can split it internally. So instead of having chain A own the entire block space region, like A, they can sort of split it internally and then sell half of it to a chain B, and then you'd have the outcome A, B, A, B, A, B, something like that. And you could do that in a bunch of different ways. Like this is not implemented. This is a design research topic that we're discussing, but the idea of sort of reselling block space that you're not using as a parachain in order to recoup costs is going to be something that's good for general market efficiency and utilization.
Yeah, that sounds really, really interesting. I'm sure all of the parachain teams are interested to hear more and read more about that as it comes to fruition.
Yeah, it's interesting stuff. Open call to collaborate, chip in your thoughts on the forum, do some building in public as we do, and hope to see your comments there.
Yeah, nice. Okay. I think that's all we had for today, unless anyone has any final questions. If you want to put them in the blue bubble at the bottom right, maybe just wait 1 or 2 seconds. If you have any furious fingers, you want to type in any questions. But if not, going once, going twice. Okay. Well, thanks so much everyone for coming. It was really awesome, Rob, to take some time out of your day and chat about this. I think it's these changes sound really, really exciting, and yeah, sounds like it's going to be some pretty cool stuff for the network to kind of see in the future. As I mentioned before, if you have any, if you want to read further or you'd like to participate or ask questions, Rob's pretty good at replying on the forum, so you can look at the pinned tweets at the top and dive into the Polkadot forum. And there's I think Rob's blog is posted there as well. If not, you can look it up. It's pretty easy. It's rob.tech, where he posted a kind of an article about this from last year, I think October last year.
Yep.
Cool. Okay. No new comments have come in. So thanks everyone. Have a good night or evening or day. Rob's blog is pinned, I see. Great. Thanks so much.
Cool. Thanks, Berto. Thanks everyone for coming.